So answers, here they come. Number 1 is Euclid. You don't have to spell in perfectly, just it's E-U-C-L-I-D. It should look like Euclid. And then pretty much open-ended, just say some stuff about it. So some things you could say: he was Greek, he wrote a book. The book was called The Elements, if you like that. That was basically the first geometry book. And then there were other things in there about him. If you're reading things that you remember reading, just go ahead and give the people their points. We're just looking to come up with 2 facts. If you're not sure, we'll do some question clarifications in just a second, but let's just plow through the answers first. 4, we're filling in the blank with the word set. 2.1, the main word of the day was set, so some more on that in a minute. 5 to 9, we're matching. C like cat, B like boy, A like the grade you want to get on the quiz. 8 is D like dog, 9 is E like elephant. So C, B, A, D, E is how the matching goes. 10, we're looking to fill in point, line, and plane in some order. But for the full answers, we want to say that a point has no area. We want to say a line has no width. We want to say a plane has no thickness. 17 is a theorem. Spelling is worth half a point on that, so T-H-E-O-R-E-M. T-H-E-O-R-E-M, theorem. 17 is blah blah geometry stuff. So blah blah geometry stuff for 17. 18 is a postulate. We have to spell postulate for a half point of value. It's P-O-S-T-U-L-A-T-E. P-O-S-T-U-L-A-T-E, postulate. For 19, it just is. 20 is a definition. 21, half a point for the first blank of category, half a point for the second blank, something like specific properties, but you could use synonyms if you have a different way to say specific properties, it's okay. 22 is 2 half points, half a point for postulates, half a point for undefined terms. 23 is a 3-word answer. If you're short one of the words, I'll give you a half. Last time I was giving you a half if you only had one of the words. Today you've got to have at least 2 of the words to get your half. It's a convincing logical argument. Convincing logical argument on 23. So as we step into next time for quiz, you need to read 2.2. As you read 2.2, you're going to encounter a lot of stuff. That's the bad news. The good news is it's almost all stuff you've seen before, but it's a lot. There's a lot in here. So one kind of thing you're going to come up with, you're going to read about some kinds of numbers. There's going to be, for the quiz, matching 5 points worth of kinds of numbers. So for example, think back to your Algebra 1, and if you had Algebra 2 days, or even back to your 7th grade math days, we started to do these. Can somebody give me an example of a kind of numbers?
Integer?
Integers is true. Somebody else, a type of numbers? Counting numbers, true.
Real.
Whole numbers, real numbers. Irrational numbers. Rational numbers. That's the kind of thing you're going to read about. Okay? There's going to be a bunch of them. I'm not going to do a question about every single one. I'm not going to make you do definitions of them, but you're going to have to match a category with like what that's about. We threw integers out there first. Does anybody remember what the integers were about?
Isn't that just whole numbers? Like,
Well, whole numbers and integers are 2 different categories. They're similar, but slightly different.
Doesn't integers include 0?
Integers include 0. Whole numbers also include 0. And the negative versions. So on my number line, I have marked all the integers. The integers are the negative whole numbers, the positive whole numbers, and 0. Whole numbers is a slightly different club. What didn't the whole numbers include?
the negative?
The negative. So read about that, refresh yourself. But that's the track of what we're on. You can read it and figure it out from there. But there's a lot of categories of numbers. We saw them in Algebra 1, saw them in Algebra 2, if you got that far yet. I'll keep all year talking about Algebra 2, but like half of you had that and half of you didn't. So that helps half of you and not the other half. but 5 matching kinds of numbers. Then you're going to read about a lot of different kinds of properties. And I'm going to not do every single one. I'm going to pick 5. We're going to do matching on some properties. So think back to Algebra 1. If you had it, think back to Algebra 2 when you did it again. Even 7th grade, we a little bit introduced some of these things. Can somebody give me an example of a property? Transitive property is a thing.
One commutative.
Commutative property, there's 2 commutative properties, one for add, one for multiply. Any other properties in your brains?
One of the additive.
There is going to be some kind of addition property. Yeah, there's an addition property of equality. That's going to be in there. Other properties you remember? Famous one starts with D. Distributive property is out there. Okay, that's again the type of thing you can read it and try to straighten it out. But I'll pick 5 properties and you're going to match. Like if I say to you commutative property, can anybody give me like an algebra sentence for the commutative property? What that was, method?
A plus B equals B plus A.
A plus B equals B plus A. That's the commutative property. So what you'll have to do is match an A plus B equals B plus A thing with the title for the commutative property. Or you'd have to match a distributing looking problem with the distributive property, or so on and so forth. But there will be 5 properties to match. Then there's one other random fill in the blank thing. You'll encounter a definition or a theorem or postulate or something else that's going to be in there. Other than numbers, other than properties, I believe there's only one other fact. So you'll encounter one other like fill in the blank kind of answer from like blue, definition-y kind of stuff is in there. So total of 11 points from the reading. But if you go through and took notes, I bet you might have like 20 to 25 notes. Okay? Because I'm going to ask 5 questions about numbers, but there might be like 7 or 8 categories of numbers. I'm going to ask you 5 matching things from properties, but there might be 10 or 15 properties. Like there's a lot of properties. We just rattled off a bunch of them. But from 2-2 reading, there's 11 points again, recapping 5 matching with numbers, 5 matching with properties, although there are more things in there than those. And then there's one other fill in the blank question about the new 11. Okay, relative to old things, if you want to just take some notes on the quiz that we took today, maybe that's the best place to write these hints. 10 to 15 is going to go back to be a 3-point question. You'll just have to say point line blank. So we're going to trim that down a little bit. But 10 to 15 still sort of there, but back to being 3 points, point line blank. Number 16, I'm going to go backward. Instead of you filling in the blank with theorem, I'm going to ask you what is a theorem. So for what is a theorem, you'll need to say it's something that we're going to prove. 17, I'm going to cut it. It'll be back for the test, but we don't need that anymore for right now. 18 is going to go backward. Tomorrow I'll ask you what is a postulate, and you'd say it's something we accept without any proof. It doesn't need to be proven. Be careful how you say that. It's not just that you didn't prove it, like you're a lazy person. It's something people are willing to accept it without it even having to be proved. So a postulate, it's accepted without any proof. 19, I'll ditch it. 20 is gone, 21 is gone, 22 is gone, 23 still lives on. A proof is still a convincing logical argument. So those older questions, that's the way that those are going to be. Question about how I'm changing from 10 down. Stuff at the top, what you're going to have to know, instead of 1 to 3 being a little bit open-ended, you're going to need the name of the person, which is Euclid, E-U-C-L-I-D, and you're going to need to know the name of his book, which is The Elements. So E-U-C-L-I-D is the guy, and his book was The Elements. Basically, he invented geometry as you know it. There's different kinds of geometry. The kind of geometry we're studying is named after him. It's called Euclidean geometry. There's also non-Euclidean geometry. There's other kinds of geometry. but our book is focused 99% of the year on Euclidean geometry. So if you want to know who to blame for this, blame Euclid. So 2 points there, name and book. Question there, summary of that. Then the other questions are not going to be matching anymore, so here's where we go with this. Instead of number 4, I'll ask you, what is a set? So what you'll say for what is a set, you'd say collection of elements. Or if you'd rather, you could say collection of members. Elements and members are interchangeable names. For example, geometry class is a set of 3, 7, 11, 14 members. Melissa is a member, Asa is a member, David is an element, Nicole is an element. We can say element, we can say member, it doesn't matter which word we use. But when you have a collection, a group of things, that is a set. Major League Baseball is a set of 30 teams. NBA basketball is a set of, I don't know, how many NBAs are there now? I lost track, I keep adding teams, about 30-ish, you know. But if you have a group, a collection of things, that's a set. So number 4 becomes, what is a set? Collection of elements, collection of members. Instead of having the matching thing, there's definitions in the book and you can find them. You're going to fill in the blank with union, or you'll fill in the blank with intersection, or you'll fill in the blank with subset, or you'll fill in the blank with empty set. Instead of matching, those are going to be fill in the blanks. The only one there that didn't make the cut was the is an element of thing. But empty set, subset, union, intersection, those are now becoming fill in the blank moments on the 2-2 quiz. Grand total that's 24 because we gained some but we lost some. So it's about a neutral thing. Quiz goes from 23 to 24 as we move from 2-1 to 2-2. Question about 2-2, what you're looking to read, learn, absorb, study, know, whatever. Homework is going to be like the sheet that came down your row about 10 minutes ago, so we're going to work from that sheet for a couple minutes. The newest homework will be page 18. Page 18 we'll work problems from 1 to 10, but let's work through the worksheet first. So at the top of the worksheet I put a bunch of sets. When we have sets, we do them as lists that are in squiggly brackets. A few minutes ago we talked about the integers. If I wanted to describe to you the integers, I would do something like that. Why is that not a perfect list of integers? The dot, 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 because it goes forever, not just in the positive direction,
And also in the negative.
but it also in the negative direction. So when we do a reading quiz tomorrow, this is going to be an answer for integers. You'll have to match it up. But that's a set. Anytime you have sets, try to practice drawing your squiggle brackets. Some people are good at that, some people stink at that, but sets are always just lists in these squiggly brackets. So across the top, I just created a bunch of sets and gave them names for conversation purposes. So A is a set that has 3 elements, 1, 2, and 3. B is a set that only has 1 element, which is 1. C has 2 elements, or 2 members, and so on and so forth. So I'm going to keep referring to those at the top for communication purposes, and then I'm just asking you to analyze whether what I'm saying is true or false. So you'll see at number 1, is set A equal to set B? No. Sets are equal only if they have the same members. So set A had 1, 2, and 3 in it. Set B had just 1 in it. Those are not equal. So you could either write false, or you could change what I wrote by going like this. A is not equal to B. That's a true statement. So you make your note however you want to make your note. But no, those are not equal sets. 2, is set E equal to set F?
Yes.
Yes, those are true. They both have 1, 4, and 5 in them. So 2 is true. E does equal F. Anybody a question judging what makes sets equal?
So they have to have the same, they have to be the exact same number?
Exact same thing. So if I'd say to you hey, Grant is in physics, Grant's also in geometry. Is the set of physics students equal to the set of geometry students? No, it's not enough to have Grant in common. The whole groups have to be in common. It's not like, question about the equal part? Okay, what's this sideways U, almost C looking thing? What's that symbol about? From our
Belongs
matching.
to,
No, not this one.
or
The symbol I'm using in 3, 4, 5.
it's a subset.
That is subset. Okay, to be a subset, you have to have everybody in the first one go in the second one. Maybe the second one has more, maybe the second one doesn't have more, it doesn't really matter. But the first group has to have everything from it belong to the other one. Like, the senior class is a subset of our high school building. Our high school building is a subset of our entire school. The subset is like, everything in the subset is in the bigger group. Maybe it's extra, maybe it isn't. So for 3, scope out set A, scope out set S. Is A a subset of S? Yes, because A has in it 1, 2, 3. S also had 1, 2, 3, and then it had some more, but we don't even care if it has more. A is a subset of S, because anybody who belonged to A belonged to S. So 3 is true. Is B a subset of A? Yes, because everything in B is also in A. A might have more things, it might not have more things, we don't care. But B is a subset of A. Is B a subset of C? No, because 1 is in B, but 1's not in C, so 5 is false. Let's go look at the bottom of the page where I have boxed off like 3 boxy areas. There's 2 truths about subsets. We're going to do the middle one first. Any set in the world has to be a subset of who? Anybody have a thought? Itself is correct. Any set in the world is a subset of itself. So that middle box at the bottom, any set has to be a subset of itself. True. 6. I could read 6 as 1 belongs to A, or A contains 1, or 1 is an element of A. Is 6 true or false? True. That's true. 1 is in A. 7. 1 is an element of C. False. False. Question about subsets or this element thing? 8. What's the U symbol about?
Union?
It's called the union. Union in geometry or in life, it just means you're putting stuff together. So when I go to do number 8 and I want to know the union of D and E, I want you to take D, I want you to take E, and I want to jam them together, and anybody who's in anything gets to be in the answer. So for 8, we go squiggle brackets, and we're going to make ourselves a new list that's probably bigger. Who would be in the list of the union of D and E? 1, 2, 4, 5. So 8's answer would be squiggly brackets surrounding 1, 2, 4, 5. Question about union? What's the 9 upside down U symbol about? Intersection. If you want to jot down to yourself, a one-word synonym for intersection is overlap. If you want to write down, it'd be a good idea to write down a key phrase. It's in common. The intersection is what we have in common. If I go back to the idea of like physics and geometry, the union of that would be like 30 kids. We have like 14 in here, we've got like 14 in physics. If we did the union of those groups, we wouldn't fit in the room anymore. There'd be like 28 of us. Who's the intersection of geometry and physics? Grant. He's who's in common. He's the overlap. Okay. To make the intersection, you have to be in both groups. So for number 9, if we look at D and look at E again, and we do the intersection this time, it's who's in common. 1 and 5. So we would do a set of squiggle brackets that surround 1 and 5. Question about ideas 1 to 9. Let's go to the bottom left corner. There's another special set that is the subset of any set. Anybody have a theory on what special set is the subset of every set in the world?
0.
Not 0, but right track.
1.
Not 1. There's a special set in the reading that had a name. The empty set. The empty set is a subset of any set. So bottom left corner, fill in one of our symbols for empty set. This can be a symbol for empty set. This can be a symbol for empty set. Pick one that you like better. Bottom left corner, the empty set is a subset of any set. So let me do a subset rehearsal for a second. If I have one set that it has A and B in it, and I want to list subsets, can somebody give me one subset of that set? Just A is true. Can somebody else give me a second one?
Just B.
Just B. Can anybody give me a third one? A and B. Because one thing we learned today is every set is a subset of itself. Can anybody do another one? Empty set. Can anybody do another one? We're delaying because the answer is
No.
no, but that's it. There'd be 4 subsets for that. If I wanted to do ABC, would you have a little bit more or a fair amount more? You'd have a fair amount more. Because now you'd have some groups of 3, some groups of 2, some groups of 1, some groups of 9. You'd have to list every group. That would grow, kind of quickly. If I went with the whole alphabet and asked you to list subsets, that would be unconscionably long of a question. Okay? But the subsets are like every group that's contained in that larger set, be it an empty set or be it the fullness of it. Question about that? Let's go bottom right corner. Are those two sets equal? A set with 0 in it, is that the same as the empty set? No. A set with 0 in it has an element. The empty set has nothing in it. And 0 is a number, it counts. 0 is a thing. So this bottom right corner, no, those are not the same. A set with 0 in it is not the same as the empty set, not equal. And then we'll go a picture-based thing. Questions at all before I do the picture-based thing? Okay, so here's the picture that I was based from for this last group. In geometry, when they use this symbol, they're talking about a triangle. When they're talking about a triangle, they're only talking about the white chalk outline. They're not including any space inside the triangle. It's just the white chalk outline. So for this first question, I'm asking you, where does triangle ABC, this white chalk outline, have an intersection, or where does it overlap, or what's in common with a line that goes from D to E? So a line from D to E is this whole space. So if I take this whole white bit of chalk and this whole white bit of chalk, where do they overlap? Where do they touch each other? Where do they cross? Where do they intersect? Those are all synonym words. Where's the touch of that? Where does this touch this?
In the middle.
Where? They have labels and location.
D.
D is a touch point.
E.
E is a touch point. So that intersection would be D and E. They used to have an old sandwich bag commercial about yellow and blue makes green. Essentially what you're being asked is the triangle, which I could do in yellow, if it crosses the line, do that in blue, where do yellow and blue get a chance to blend and make green?
D and E.
Right there and right there. That's a point, that's a point, there's 2 points. D and E, those 2 points are the intersection, the overlap, where yellow and blue makes green is that. Question about that one? Let's do the second one of those. I'm going triangle ABC. Just redraw. I'll go yellow though. triangle ABC is yellow. Then line AB, this is line AB. Now what do we have? Yellow and blue make green where?
At the, like the whole side.
Yeah, this whole side, from here to here. All of this is overlappy stuff. What kind of geometry word is that green thing? What is that? From here to there with a beginning and an end.
Line segment.
That is a line segment. Okay, this was B, this was A, so this answer would be line segment AB. This is the official geometry abbreviation for line segment, if we did a line segment. If you're doing the line segment, little hat, you don't have to do this anymore. If you want to do that, you can. I'll do those gently, lightly there, but if you want to do the squiggle brackets, fine, but when you do the line segment hat, you've got yourself covered. You're in set now with that. Question there? Then let's do a yellow line DE. So if I replicate yellow line DE, there we go. If I replicate in blue, segment AC, segment AC is down there somewhere. So we've got this DE thing going there in the picture. We've got this AC thing going there in the picture. This time, where does yellow and blue have a chance to make green?
Never.
It never does. That has a name today that we learned. That is the empty set. If things never touch each other, we could go with empty set. You could do that symbol, or if you prefer this symbol, you can use this, the squiggle brackets with nothing in there, just pick one. But that's the kind of things you're going to do tonight on the page 18. You're going to be doing yellow plus blue makes green on the intersection questions. Where do they overlap? What's in common? That kind of thing. The page 18 is going to work a 1 to 10.